There we go. Okay. All right, so this is the first chapter this semester where we are dealing with equations that do not make straight lines. So up until now, we have only dealt with equations in one variable or in two variables. So like either solving for x or some variable or an equation in both x and y. I see some computers and cell phones out. You guys can put those away. All right. Raise your hand if you have heard the word polynomial before or dealt with polynomials in the past. Great. Okay, so a polynomial, linear equations make straight lines when you graph them. Polynomials make curved lines. Okay? And they tend to have powers or exponents of greater than 1. So a monomial is a real number, a variable, or a product of a real number and one or more variables with whole number exponents. The degree of the monomial is the sum of the exponents of its variables. So, for example, give me some random letters and numbers.
D, O, no.
Okay, D3. All right, let's say we had 3, D, R, 3 doctors. Okay? The degree of a monomial is the sum of the exponents of its variables. Which of these are variables? The D and the R. What are the powers of those? 1. So the sum of 1 plus 1, this would have a degree of 2. Likewise, if this was instead D squared R cubed, this has a degree of 5. Exactly. This is a monomial. Okay, it's one term. There are no terms being separated by addition or subtraction symbols. All right, a polynomial is a monomial or a sum of monomials. So, for example, if you had 2x squared plus 5x plus 9, this is a polynomial. This term has a degree of 2, this has a degree of 1, this has a degree of 0. The degree of the whole thing would be the highest degree, the term with the highest degree. Which term has the highest degree here? This one, right. So the degree of this polynomial would be 2. I have provided a chart with some examples. This is an example of a monomial, a binomial, a trinomial, another monomial, another trinomial. The degrees are 0, 1, 2, 3, and 4, etc. Any questions on the terminology? Yes.
Will we have to memorize this?
You may have to give me the degree.
Okay.
And in general, when you are writing the answer in polynomial form, the degree should be in descending order. So the term with the highest degree should be in front, and then in descending order. Yes? It says degree twice. So this is the number degree, and this is the name. There might be one where I say, is this a linear equation? Like, you should be able to tell me if this is a linear equation. Yeah, or if this is a quadratic. Okay, I'm going to make this A, B, and C. On your whiteboards, please give me the degree of each monomial.
You have more than one time, right?
You know what? So ladies, because there's only so many answers you could give me, like it's either 1, 2, 3, 4, 5, it's some small number, you only have one chance to answer. So check with your teammates, make sure everyone on your team agrees before you hold up your board. You're good? You checked with your teammates already? Yeah? Okay. Okay. Okay? 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 2, 4, did you guys answer? everybody got them. The only one that people missed was the last one. So remember, the degree is the powers of the variables. This has no variable, so the degree is 0. Any questions? Okay. Okay, so sometimes when you are adding terms together, most of you I did not have last semester, but I'm assuming that you guys went over like terms. How do you determine if two terms are like terms? They have to have the same variables and they have to have the same exponents. Perfect. Okay, so in this case, for example, these are like terms and these are like terms. Please simplify that first expression. Oh no, I'm throwing things.
Wait, that's what I thought. What did you say? 11?
Yes. This one you can answer more than once.
I didn't know if it was that or if it was like. Oh,
Yes. No, sorry.
I was thinking but
No, sorry.
Like go back.
Yeah, you have to sign out. I'll give you guys 1 more minute.
Oh, yeah, but
Nope, sorry. Nope, sorry.
I was just dead.
Yes. Please help each other out. Yes. Make sure your teammates understand how to do this. Yes. Nope, sorry. You're missing an R. You got it.
Twice. So there? Oh my gosh, I'm so going now.
Yes. You guys have it? Yep. It's not right. I'm sorry. Let's go over. Let's go over. All right. So, because
Very fast.
I guess I could take some volunteers. All right. Would anyone like to solve this problem up here for a bonus point? Go ahead, Michaela. You volunteer every day. I want to spread it out.
I'm gonna fight you.
Don't fight me in class.
No, not you, Michaela.
Oh. I'm pretty sure there's something in my contract about not, exerting physical violence upon the students.
I did karate for 3 months. Wait, no.
Okay, so
All right, ladies, everyone, please quiet down and give Michaela your undivided attention.
so since 5R and 6R are like terms, you're gonna add them, so it becomes 11R, and then the exponents don't add; you just keep them, so it becomes 11R to the third plus 8 plus 3. That's 11. That's your answer.
Well done. Thank you. Any questions? All right. Okay, this next one. Before I let you guys try this, tell me, what do you... Yes. Sorry? Okay. Is it the first term or the second term or the adding? So, in order for terms to be like terms, they have to have the same variables and the same powers. Okay? Okay. All right. Any other questions? Okay, before I let you guys try this one, can you tell me what to do with this negative? Distribute it. Okay, go ahead.
I would think it could be. Is it this? Try it.
Nope, sorry. Yes.
Minus 3?
Thank you. Sure thing. It's not right, sorry. It's not right. That's right. Nope, sorry.
Did we get it right?
No, I haven't seen it right.
Oh, have seen it?
That's right.
No, she's seen it.
2 teams have gotten it right. Nope, sorry. I see the mistake you're making. It's a super small arithmetic mistake.
3x.
Nope, sorry.
3x. Oh! Wait, we gotta answer.
Remember, terms have to have the same powers to be like terms. Team 5, great job. Team 2, great job. You guys, 1 more minute.
Wait, negative. Oh no!
Remember, to be like terms, they must have the same variables and the same powers.
Oh, they don't combine them. But we got an answer.
Okay.
Wait, give me process. What was this? I don't know. It's not fun. So,
Erase the. Oh, well, now it's not right. I'm sorry.
almost done.
It's close. It's very close. It's so close. It's not right though.
Look, he tells. Oh!
It's still not right. It's so close. It's so close. Yes, yes, that's right.
Ah. So that's
Yes.
kind of
Yes. Good job, ladies. So you can't combine the x squared and the x. We'll give it one more try.
What? Wait, why is it second? Oh, no. X is second power plus 3x. It's going to be minus. Look at the minus. Yeah. So it's marker sub. JK.
The 3 is incorrect. Because -5 and -2 minus 5 is. Where'd the x squared go? Well, what is -2 minus 5? Yeah.
They put your CD in your paper? Yeah.
You put -3. All right. Would someone like to come up and explain this problem for a bonus point?
I want to do another one. This is kind of hard.
Come on.
Guys, we're losing. It's number 4.
All right, ladies, everyone, please quiet down.
Okay.
Please quiet down.
Can I?
Yeah, I know. It's always in the way. I'm sorry.
Okay. So first, well, I just have to write it down.
You can also see it on the screen here.
Oh. So I'm just gonna write it down. So first we need to distribute the negative. So I'm just gonna put negative here, -1, and it's gonna be -3x and -5. We just put down the x squared and then -2, and this is like terms. So this is -2 plus -5 is -7.